Hello folks, I'm going to attempt to tell you how to do or show you how to do a unit weight test. First of all, you are going to get your sample and it's going to be dried to a constant mass at a 230 plus or minus 9. Remember that, that's very important on a lot of these tests. So we got our sample dried, and you want 125% to 200% of what you need to fill this apparatus. Now to choose our apparatus is depend upon your nominal maximum size. Here we have a apparatus. It takes a little under 2 to make a cubic foot. This one here, it takes 3 of these to make a cubic foot. And here we have one that takes 10 to make a cubic foot. So since we're dealing with 57 gravel and with a nominal maximum size of 1 inch today, we're going to use the 1/3 cubic bucket. It takes 3 of these to make a cubic foot. We want to make sure the apparatus is pretty clean, dry. And then we take our sample here that's been oven dried, stir it all around. Try not to lose any of it. Well, don't lose any of it. After you get it stirred, you're ready to start. So you want to fill this bucket up 1/3 of the way full. Put that in there. You want to kind of just put it in there in a circular motion. Kind of level with your fingers. Make it level. And we want to rod 25 times, but we are not going to strike the bottom of the apparatus. There's our first lift. On this lift here, we're going to rod 25 times, not all the way to the bottom, but down to the next layer, the first layer that we have put in there. Okay, we're ready for our last one. On this lift here, it doesn't. You're going to be humped up a little bit because you're going to anticipate as you rod that's going to fall a little bit. Okay. Finishing touches on the top, what we want to do is you want a pretty close to the amount that's sticking above the top as many as sticking below the top. Just kind of reposition some rocks here. I'm going to call that pretty close. So what we're going to do now, we're going to get a weight on this, and then we're going to dump this out and we're going to do it again. And our test results has got to come within 2.5 of each other. So here we have our weight. That's the weight of the bucket and the material that's inside the bucket. You record that weight. Then you dump her out. So we're now ready. You stir it up and go through the process again. Once again, this is for the rodding procedure. Okay, this is a kind of an explanation on how you calibrate your vessel. You zero your scales off. You put this on there. You're going to take a little bit of grease and you're going to go around this rim. You don't have to slop it up real good. Just you're looking for something to seal between the top and this glass. So you got your apparatus, you got your grease around the rim, and you got your glass here. So you want to get a weight on that. So then after you get that weight, you write it down. Next thing you're going to do is you're going to fill this up with water. We put a pencil under the edge. You're going to fill this up, and that's I'll explain that here in a second. You're going to fill this up with water, and you're going to set this on there about this far. And then you're going to take a little squeeze bulb, and you're going to squirt water in there until all the air comes up and out there, and then you just go ahead, slide that over there, and make sure you have all water and no air bubbles. You take your pencil out, and you get your weight. You get your weight, you got to get a temperature on that water, and then you'll have to go to this density table here. It shows your temperatures of the water and the density of that water. So then you record those numbers, and you go back and you do the calculations on how to come up with the correction factor. Kind of self-explanatory on the forms. Calculate the factor by dividing the mass of the water that you had to use to fill this measure by its density. The factor is carried out to 3 decimal places. You divide the density of the water at the temperature taken into mass of the water. This value should be divided into the mass of the aggregate determined to give your unit weight.